Hello, everyone, and welcome to Data Platform Virtual Summit 2021. My name is Amit Khandelwal, and I'm a senior program manager with Microsoft working on SQL Server on Linux and SQL Server containers. Before we start the session, I would first like to thank you for making time to attend this session. So now talking about the session on what we are going to discuss in the next 60 minutes. So this session is about SQL Server on Linux and how you can make the deployments of SQL Server on Linux easier so that you can go ahead and deploy this on production scale and deploy them in an automated way and scale them when you need it and scale them down when you don't need it. Not all options have those facilities, but we will talk about the different options that you kind of have for deployment of SQL Server. So with that said, I think it's time for us to now jump in and look at what the agenda looks like for this session. So to start with, what we're going to look at is we're going to look at the different options that you today have to deploy SQL Server. So when you want to deploy SQL Server, what are the different options available? What are the platform options available? What are the infrastructure options available? We are going to take a look at that. And once we've seen that, then we will jump into the different deployment methods that you today have using which you can go ahead and deploy SQL Server on Linux. Now, a quick talk about my another session that I want to go ahead and present. So in this session, the focus remains for SQL Server deployments on Linux, which is for bare metal, which is VMs, and this could be deployed on premises, this could be deployed on cloud. But for SQL Server and containers, I have another session which is coming up, which talks about SQL Server container deployment using Helm. So in that session, I'm going to talk about SQL Server containers. So if you're interested and if you're looking forward to run SQL Server containers like most of the other customers today are running SQL Server containers, if you would want to go ahead and do that, then please do attend the another session that I have lined up, which is titled as SQL Server deployment on containers using Helm. Cool. So here we'll take a look at Ansible based deployments. We'll take a look at JujuCharm based deployments as well as the Terraform based deployments. And then we are going to go ahead and look at the day two level of operations. How would you go ahead and set high availability for SQL Server on Linux? I'm sure you all must be aware of pacemaker clusters, CoroSync. We are going to look at more. What other options do you have when you go ahead and deploy SQL Server on Linux? So we are going to look at the HA options, and then we are going to close this session by looking at how you can set up a near real-time monitoring for SQL Server on Linux. Now, this monitoring setup that we will do this on a TIG platform or a TIG stack, as they would call, which is Telegraph, Influx, and Grafana. But we'll also take a look at the other option of monitoring that you kind of have available. So with all that, I think we have a pretty loaded session. And did I say that we are also going to take a look at the demos? Because we have about 30 minutes of demos and 30 minutes of sessions. So let's get rolling and let's get started. Cool. Now let's talk about SQL Server deployment. Now, this is really interesting because I just want to go ahead and show you the different options that you have today to deploy SQL Server. So if you're ready, here goes the options that you have. So as you can see, this chart is really big. I mean, you can see yourself that you have an option to deploy SQL Server on Windows, or if you want to go ahead and deploy SQL Server on Linux. In Linux, you have various supported platforms like SLES, RHEL, Ubuntu that's available for you to go ahead and deploy. And these infrastructure could be on premises. This could also be on VMs, which is probably Azure VMs on cloud. So you could go ahead and deploy there. The other option that you have is running SQL Server on containers. Now, again, container deployment could be a standalone container deployments, or it could also be container deployments on Kubernetes environments. And we do support Kubernetes 1.16 version and above all the deployments for SQL Server. So you can go ahead and choose a managed Kubernetes platform such as Azure Kubernetes Service or Azure Red Hat OpenShift, and then deploy SQL Server containers on top of that and use Kubernetes platforms, HA availability, high availability solutions. You could use the manageability, the replica set to manage containers and pods. You could use that to manage SQL Server, or you could go ahead and deploy your own Kubernetes deployments on premises and then deploy SQL Server containers on top of it. So as you can see, you have a lot many options available with SQL Server 2019 deployments. And some of these deployments are also possible for SQL 2017, because SQL Server 2017, starting SQL 2017, we had these options of deployments available to you. So with that said, one important aspect that I would like to talk about before we move to the next slide is that you choose to deploy SQL Server on Windows, you choose to deploy SQL Server on Linux, or you choose to deploy SQL Server as containers. The backend SQL Server engine that is running for all these three deployments is the same SQL Server engine, which means I could just take a backup of the database from a SQL Server on Windows and restore that on SQL Server on Linux, and vice versa. I could take a backup from SQL Server on Linux and restore that on Windows or on containers without any problem. So same thing, you could take a backup from SQL on Windows and also restore it on containers as well. So that basically means if all the parameters are the same, the environment is the same, we even expect the SQL Server plan to be the same, because that's the same SQL Server engine which is running behind SQL Server on Windows, SQL Server on Linux, or SQL Server containers. So with that said, I think now it's time for us to go ahead and look at the different deployment methods. Now, as I said, we have multiple methods. The first method that we are going to look at, and which is very, very popular in the open source world, which is the Ansible way of deploying SQL Server. Now, I'm not going to go deep dive into what Ansible is, how it works, what are the components, but I would definitely like to present a crash course, a 101 class for Ansible. Now, what is Ansible? Now, Ansible is basically an open source platform that's been created to help you make those repeatable tasks, to go ahead and automate that repeatable task that you have. So okay, let me put this way. So you have to go ahead and do a certain installation, and every time that you go ahead and create a new VM, or you go ahead and configure a new machine, you need to go ahead and install a specific program or a specific package. You can automate that using Ansible platform. So it basically provides you that option. So overall, the most use cases that I've seen with Ansible is used by the DevOps engineering team to actually create and build a pipeline which helps them automate those most administrative tasks. And also I've seen something system administrators use it very, very frequently to ensure that they can go ahead and those tasks which are very repetitive in nature can be done using Ansible roles and Ansible system roles. Now, with that said, one good thing about Ansible, it's completely procedure based. It's not declarative based. So it's more like a running YAML file that you can provide. And based on that, you can create modules and functions and plays, and then you can go ahead and run those tasks with them. So with that said, what does the architecture consist of? Now, the architecture basically is that you don't have to manage multiple nodes using Ansible. You just need one controller node. Now, think of the controller node as the node on which you go ahead and install Ansible, and then you have multiple target nodes or managed nodes, which basically are controlled by this controller node. So the idea is, from this controller node, which has the Ansible installed, Ansible's roles or Ansible installed on it, it can go ahead and connect to these managed nodes, and then do the deployments that you would like to automate using this Ansible system roles. And the good part is that on these managed nodes that you're trying to control through the controller node, you really do not have to have any tool installed. So it's completely a agentless tool. So you don't have a tool or a service or an agent that needs to be installed. All you need to take care is there is a way in which controller node can talk to these managed node, and that way is through SSH, or the setting up passwordless SSH access between the controller node and the managed node. So that is how the architecture is. And once you have that defined, then you have something called as modules, and group of modules are tasks, which are basically what you're going to go ahead and automate. And these group of tasks are called as plays, and these group of plays are called as roles. So using a role is nothing but a collection of multiple tasks which are stitched together, and they kind of go ahead and provide you the automation that is kind of necessary. Good. With this information about Ansible and how the architecture looks, we are ready to talk about SQL Server System role. Now, we've worked very closely with our partners in the Red Hat Enterprise Linux team, and they've gone ahead and provided and created a system role, ready-made SQL system role that's available for you to go ahead and use right away. The link for it is provided in this slide. The Ansible Galaxy is where you have the system role already created. As of now, this system role is not supported by Red Hat or by Microsoft, but you can still go ahead and start using it and make customized changes as per your environment and start working it, because at the end of the day, it's just a way of automating the deployments of SQL Server. So you're not doing something, you're not going ahead and creating something new. You're just automating the deployment of SQL servers in your environment. And I think this will be much more clearer when we go ahead and show you a demo, which is probably the next slide that I'm going to show you. But I would want you to at least go ahead and take a look at this GitHub project and see if you can get started. And if you've already worked with Ansible, this will be something for you to, as a starting point from where you can build your own customization scripts. Now, this link is already provided in the first pointer that you have there. The second pointer that I would want to thank our friends from the Red Hat Enterprise Linux teams is for providing us this interactive lab where you don't have to set up any machines to start trying this. What you can do is you can just go ahead, click on this link. It has a virtual lab built into it, and you can try the system role as is on that particular lab. Now, if you are more of a person like me who likes to set it up from the scratch and build machines and then try things, then I have a demo for you right now. So before we go ahead and take a look at the demo, let's see what are we going to do in this demo. So here is a quick diagram, a Visio diagram for explaining what the demo is all about. And here, what you see here, this is basically the controller node where I have my system role installed as well as the Ansible installed. And then server 1, server 2, server 3 are basically 3 managed nodes that I'm going to go ahead and deploy SQL Server on through this controller node. And I have a passwordless SSH access enabled between the controller node and these servers. So that way, my Ansible can connect to these servers and then start deploying or perform the actions that are mentioned in the playbook. And playbook is nothing but the collection of the modules and plays that the task that I'm going to try and automate. With that said, I think it's now time for us to go ahead and take a look at the demo.
Okay, it's now time to show you the demo for the Ansible system roles. So we already have the Ansible system role created and uploaded on the Ansible space. So you can go ahead and take a look at that from the slide. So in this demo, what I'm going to do is this is my controller node. This is a relay box, which is my controller node. So because this is my controller node, I definitely have Ansible installed here. So you can see the version. So I have Ansible installed here. And because this is my controller node, I am going to use this to go ahead and control the other nodes. Now, the hosts that I want to go ahead and control are basically added under this property, which you all probably are aware if you've used Ansible. So here I've just gone ahead for this demo. I've just added one server on which I'm going to go ahead and run my SQL Server installation and deployments. But you can definitely add a group of servers here and be able to deploy at once across all those groups of servers that you have. And of course, you could group them as a single collection and then run it against a collection as well. So all of that is possible like you would do. Now, this is just a quick setup shown with Ansible and how we've configured Ansible. Now what we need to do is install the SQL Server role that's available. And to do the installation, you have to just go ahead and run this command. I'm not going to run this. I'm going to just stop this command right now because I already have installed my role and the role is present here. So you can see all the files created here, the roles created here for SQL Server. And the only file that doesn't get created is the playbook YAML, because this is something that you have to configure. So when you look at the playbook YAML, you'll basically see the different actions that I'm going to perform. So here you can see I'm going to install the tools, I'm going to set up the password, then I'm going to go ahead and install the evaluation edition, enable agent, tune it for FUA storage, which means I'm going to go ahead and add MSSQL configuration with trace flag 39799, write control through, write flags and other flags for FUA storage, install PowerShell, install full text search. So I'm basically doing a lot of actions using this playbook YAML. So to go ahead and run this, what I've got to do is simply run this command here. So let me just clear this. Simply call the playbook YAML file and run it as user root. And the most important step is the host that you're trying to control through this controller node. Between the host and the controller, you need to have a passwordless SSH setup, which I've already done to save time. And as soon as I go ahead and click this, you'll see the playbook has started. So this is the server. It's basically going ahead and installing SQL Server. As you can see right now, SQL is not installed and the process has started, which goes ahead, connects to the host and starts deploying SQL Server and all the actions that we've configured in the playbook YAML. So just to save time, what I've done is I just have the output shown here. So this is how it would look. So as soon as we start the playbook, it's running on the other tab, but I'm just switching the tab to just show you how the output is going to look. So it's going to go ahead and configure the repository, install SQL Server, check all the artifacts are available or not, set up the SQL Server, even set up the TuneD profile as per the recommended configurations for SQL Server, and then do a lot of other things like installing, setting up the passwords, installing the tools, installing the full text search, setting up the right editions of SQL Server, setting up the TCP port. So you can basically go ahead and run SQL commands as well if you have any. Also, you could go ahead and configure the FUA, trace flags, PowerShell packages. Pretty much you can go ahead and write your own playbook YAML file and control the deployments the way you would like it to be controlled in your production environment. With that said, let's just take a quick look and see if the setup has started. So as you can see, the setup has started. In fact, it has gone ahead and now is in the process of installing FTS. So if I just go ahead and run this, I should probably see it active and running. So there you go. You can see it is active. And if I just run a TuneD profile list, you would see it is probably using, yes, virtual guest MSSQL. So there you go. I mean, this is still running. It might take a few minutes for it to go ahead and install, but at the end of the day, what I want to really show is using the system role, I was able to run SQL Server installation on one host. Using this, you can just add multiple host entries into your Ansible configurations and start running it across multiple hosts at once. So that is the power and that's the ease using which you can go ahead and run. As you can see, pretty much the entire configuration finished and my SQL Server is now up and running over here with the right TuneD profile and full text search also installed.
Okay, now we've looked at the Ansible demo. It's time for us to look at the second option that we have, which is creating or automating the deployment of SQL Server using Terraform. Now, as you would know, Terraform is a tool again which is used for automation, especially to go ahead and deploy infrastructure on cloud. And this is something that we have already worked with our partners in SLES, and with their help, we've also created another GitHub project which you can go ahead and clone to and start working with this project. Now, what does this project do? So this project is based on Terraform, where we use Terraform to actually go ahead and deploy SQL Server on SLES 12 on Azure VMs, and then expose that as a public endpoint and make that endpoint available to the customers so that they can go ahead and connect to the SQL Server. So just to put it in a reference, what we are going to do is using Terraform, we basically go ahead, and this GitHub project is also available and the link is also provided for your reference here. So using this, what we basically do is we create a private network first, then set up a subnet inside it, and then deploy a Azure VM, which is a SLES 12 based VM on in that subnet. And inside that VM, we also then go ahead and install SQL Server and apply some of the best practices that are there to run SQL Server. With all of this, then we expose a IP address so that customers can go ahead and connect to that, to that SQL Server that has just been deployed on Azure. So to go ahead and show you this, I already requested my colleagues from or my friends from the SUSE team to actually share their demo on that. And here I'm going to go ahead and play this video, which basically takes you through the journey of how you can use Terraform to actually go ahead and deploy SQL Server. So let's go ahead and take a look at that video.
Okay, so I'm gonna get started right away. We don't have a lot of time for this session. It's gonna start this off with a Terraform apply. I've already created my Terraform templates here in the HashiCorp language, and I also have a Azure account ready with a subscription that we're going to be deploying to, and I'm already logged in locally with the AZ CLI using the AZ login command so that my local machine is authenticated to create Azure resources. So it looks like Terraform has come back with a plan of what it's going to do. It's going to create 11 resources here, nothing to change, nothing to destroy. So I'm going to go with yes. If there were already resources and are deployed in Azure already, here we would see, some resources to change in place if it's possible. And if we were actually tearing it down, this would, appear here. So it looks like the resource creation has started. It's creating resource group, network security group, application security group, security rules, some subnets, and also our compute resource here, a virtual machine scale set for SQL Server. So while this is running, I wanted to, it's going to take a couple of minutes, so I'm going to show a diagram here of what we're actually deploying so you can kind of visually see it. So this is the resource group that's created, that's going to contain all our resources, and then within the resource group, we're going to create a virtual network. This is so we'll get like a private network to work with, as well as 2 subnets. I'll talk about this one in a second, but this first one is going to contain our SQL Server instance, and also a security group that's attached to the network interface of SQL Server so that we can control access to it. SQL Server by default listens on 1433, and pretty much we pretty much don't need anything else in order to connect to it besides maybe SSH to the machine. So port 22 for that. So just those 2 should be sufficient for what we're doing here. In addition, we'll be attaching a public IP to the network interface as well, so that we can connect to the SQL Server instance from my machine to Azure. So this is what we're deploying here. I also wanted to show an alternate deployment, alternate architecture is using this other subnet to create a jump box here, or what we call like a bastion. And so instead of having the public IP attached to the network interface of SQL Server, of the SQL Server virtual machine, we'll instead attach it to the virtual machine of the Bastion or the jump box. So this allows SQL Server to be deployed without a public IP and just using a private IP. And if we need to get to the SQL Server instance, we'll go through the jump box. We'll first SSH into the jump box, and then maybe run some queries against the SQL Server there. This is generally a best practice. You don't want your database to be exposed to the internet, having a public IP when you really don't need to. Typically, a application would be running in another subnet or here that would connect to the SQL Server instance. So it doesn't really need a public IP. So this is generally a best practice for security and pretty common in production scenarios. But for the purposes of this demo, we'll just stick to this for ease of use. So it looks like the deployment has finished here. And one of the final steps in the deployment was to essentially output a file containing the hostname of the SQL Server virtual machine. So that's this SQL Server YAML. Let's just take a quick look at that. So it's just a single line with the FQDN as a key and then the value of the hostname. So I'm just going to copy this. Since the instance takes a little bit of time to come up, and SQL Server itself to start in the virtual machine, we want to check to see if it's actually listening on the port before we actually try connecting to it. So I'm just going to write a small bash script here to check to see if the port is actually open yet, or if the SQL Server is actually listening yet. So we'll do this with netcat. So while true, we'll use netcat to connect to the SQL Server instance on port 1433. And then we'll sleep for 1 second and continue forever. Okay, so it looks like it's kind of thing will give it some time to essentially settle here. It might stop listening on the port on this port for a second, so just give it some time to settle. But one of the main reasons we want to wait for this is, for it to make sure that it's listening, and also to set our own password. So when this image, this image that comes with SQL Server essentially sets SQL Server with its own password, a default password that we may not know what it is. So we want to set our own here, and that was one of the configuration that we used to provide to Terraform. And this is just a simple JSON-like interface to configure our Terraform templates. And the password was one of them. So essentially it would stop the instance, set the password, and then restart the instance back up. Some other configuration here is the instance size. Here it's standard v4ms with a single instance. And then some other configuration here for the OS. So the name of the user that we use to SSH to the machine. So the username of the operating system. In this case, this is the SLES OS here, as well as a pointer to the public key that's used to SSH to it. This is actually dropped into the authorized users file, so we can SSH to it. Jump box here is for configuring the jump box, like I mentioned here. We're not doing this, so false is fine. The region where we're deploying to, which is West US 2, as well as some user-defined key value pairs, like our environment. This is just for if we want to query our resources, but essentially these are attached to tags of the resources created. So it looks like it's listening, it's kind of settled down now, so we should be able to connect to it. Just gonna stop this. And I've installed the SQL Server extension here for VS Code, and we should be able to use this to connect to SQL Server. It's pretty nifty because everything's already integrated in the IDE here. So let me just copy the host name here and set up a new connection. So the host name, database name is, we don't need to put anything here. we're going to use SQL login to connect to it as the SA user. And also the password here. So let's copy this, paste this here. Yes, I want to save the password. I don't need a name right now, so the default is fine. Okay, it looks like it's created and connected, and it's showing up here. So it looks like the deployment went successful. You can see the default databases here and other things that I just created. So this concludes the demo.
Perfect. So now it's time for us to move back to the slide. Okay. So after looking at the video for Terraform, so you've now looked at the options of Ansible system roles. You've looked at the Terraform templates. Now it's time to look at the third option that you have in your automations, which is JujuCharm. Now, before we look at how SQL Server can be installed with JujuCharm, again, I'd just like to quickly go through what JujuCharm is and how can you go ahead and then run SQL Server or deploy SQL Server using JujuCharm. So first, what is Juju? Juju again is like Terraform and like Ansible is another method or another option available for open source deployments, which can help you deploy and manage software packages on cloud environments or as well as on-premises environments, again programmatically. What is Charm then? Charms are nothing but like how you have system roles for Ansible, you have Terraform templates for Terraform. Similarly, charms are nothing but set of scripts that are used to deploy a specific package or a software in an environment. Now, with the basic understanding of what Juju is and what Charm is, the next level is about SQL Server and JujuCharm. For this, again, we already have a GitHub project that is running, and all our thanks to our Canonical team, the Ubuntu team who have created this project, where you can go ahead and clone this project. And what does this project do? It basically goes ahead, uses JujuCharm to go ahead and install SQL Server, and just not install SQL Server as a plain SQL Server, but it also goes ahead and sets up Pacemaker cluster for you. And on top of those Pacemaker cluster, it deploys HA clusters for SQL Server on those Pacemaker clusters. So all of that deployment is all pre-configured. So if you want to go ahead and deploy this, you can choose what is the Azure VM size that you would want for your SQL servers to run on. Once you choose that, you can choose the resource group. You can choose the location where you would want the resource group to be created in Azure, and then automatically it goes ahead, installs Ubuntu VMs, then on top of it configures Pacemaker clusters, and then goes ahead and configures SQL Server HA clusters on top of those Pacemaker clusters. All of that is done all through scripts without running a single command to run the installation for SQL Server, or without running the installation for Pacemaker clusters, CoroSync, or configuring HA cluster on top of Pacemaker cluster. So if you want to go ahead and try that, please go ahead and take a look at the GitHub project that's available, and the reference link for that project is provided in the slide that you are looking at. So with that, we've covered three different options. So we've spoken about Ansible system roles, we've spoken about Terraform deployments, and we've spoken about JujuCharms. Again, I'd like to reiterate that it's your choice, your preferred choice of automation that you would like to go ahead and run with. So if you are someone who is very comfortable with Ansible, then you can go ahead and use that system role that was shared on the Ansible Galaxy. If you're very comfortable using Terraform, then there is a GitHub project already working with Terraform. If you're very comfortable with JujuCharms, then you also have another GitHub project as a sample available for you to go ahead and create your own JujuCharms, your own Ansible system roles, or your own Terraform templates to go ahead and deploy SQL Server. And that is something that makes SQL Server acceptable to the ecosystem, and with the help of ecosystem, you can start deploying SQL Server containers. Cool. With the different deployment options seen, it's now time for us to go ahead and take a look at the day 2 level of operations. And when I speak about day 2 level of operations, the first thing that comes into the mind is how am I going to go ahead and set up the HA, the high availability for SQL Server on Linux. Again, my focus for this session is high availability for SQL Server on Linux. High availability for SQL Server on containers is another topic that I cover in the second session. So if you're attending this, I would hope and wish that you would also attend the next session so that you can understand about the different high availability solutions that you have for SQL Server on containers. So coming back to this topic, talking about SQL Server on Linux, before I talk about high availability for SQL Server on Linux, again, for the sake of the audience, to keep everyone on the same page, let's go ahead and take a look at a quick crash course. We're just going to spend about 2 minutes on understanding what always on is really about. The first thing is always on is actually an umbrella term that is used for two features of SQL Server. One is availability group, and the second is the failover cluster instances for SQL Server. Now, I'm sure, I'm pretty sure that most of you must be aware of what availability group is, what failover cluster instances is. But again, just to bring parity, quick 30,000 level 30,000 feet description about each of these. Availability groups provide you the database level protection. Each node that participates in this cluster is basically called as replica. They don't have any shared storage. Each SQL Server instance has its own storage, and the failover, as I said earlier, happens at the database level, and the data can be replicated between the two replicas or between multiple replicas, either synchronously or asynchronously. Whereas for failover clustered instances, it's an instance level high availability option, which means that it provides you high availability outside the scope of a database. So if you are looking at, if you have certain set of jobs, or if you have certain set of, let's not say jobs, but let's say if you have certain set of logins that you've got created, it basically goes ahead and provides you that instance level failover capabilities. Now it needs a shared storage. It cannot work without a shared storage. And the most important part, only one node can at any given point of time own that SQL Server instance. So always on, please remember, is a collective term that is used for both availability groups and failover cluster instances. So it's not always on, always does not mean availability groups, or it does not mean just the failover cluster instances. It means both availability groups and failover cluster instances. Good. With that said, it's now time for us to talk about availability group always on options available on SQL Server and Linux and containers. Now, when I'm going to go ahead and speak about availability group, most of the concept that I'm talking now also applies for failover cluster instances as well. So the concept that for you to go ahead, for me to be able to explain to you, I'm taking availability group as an example. But as I said, most of it, what we discuss here, also applies for failover cluster instances. For SQL Server on Linux, we have something specifically created where earlier you could set up you could run SQL Server only on Windows, right? So you had Windows failover cluster. But because in the world of open system, we have SQL Server on Linux, we have multiple clustering options. We came up with another cluster type called as external. So you can now have cluster type as external, or you could have it as none. For always on availability group to be established and to be having automatic failovers, you will need availability groups to be set up with all, the cluster type set up to external. Now, the clustering solution that comes up for Linux comes from various partners. You could go ahead and have a pacemaker cluster, which you might all be aware of. You could go ahead also have other clusters that can be set up, which are completely supported for SQL Server. So you can go ahead and use HPE's Service Guard clusters, and then run SQL Server on top of HPE Service Guard. So you don't need pacemaker clusters then, because HPE Service Guard provides you that clustering solution on that Linux, and it's a completely supported solution from HPE. And SQL Server running on top of HPE Service Guard is a completely supported solution from SQL Server side, from Microsoft side. So you can have a completely supported solution running SQL Server on top of HPE Service Guard, or you could also go ahead and run SQL Server on top of DH2i DX Enterprise. I am going to spend a lot of time talking about the DH2i DX Enterprise clustering option in the container session. In this session, I'm going to spend more time explaining about the HPE Service Guard clusters. Now, why am I going to talk about HPE Service Guard cluster and not talking about pacemaker clusters? Is simple, because we already have a lot of documentation that's available on pacemaker cluster, how you can set up pacemaker clusters, how fencing can be set up, what are the different dependencies that can be set up, how CoroSync can be set up. All that information is already available with the pacemaker cluster. So I'm not going to go ahead and talk a lot about pacemaker clusters, but actually show you a demo with HPE Service Guard cluster, which is another option that you kind of have. Again, to reiterate, these are the different set of options that you have. You have the choice whether you want to go with pacemaker clusters, HPE Service Guard clusters, or DX Enterprise clusters. That's a choice that you have when you would want to go ahead and deploy SQL Server on Linux. So with that said, it's now time for us to quickly take a look at a video that has been provided again to me from the HPE, from our friends in the HPE, which talks about how you can go ahead and set up HPE Service Guard clusters and on top of it set up SQL Server AG. So let's go ahead and take a look at that video now.
Service Guard integrates with Microsoft SQL Server on Linux and provide easily deployable workloads for AVO AI. Let us proceed to discuss further on this workload. Service Guard AVO AI workload provide HA and DUR for availability groups which can be deployed from Service Guard Manager or CLI. Once deployed, the workload monitors the AG and SQL Server process. Service Guard uses a robust mechanism to promote the best and most up-to-date secondary replica to play the role of primary replica in case of a failure. It also supports RPO-based failover and multiple AG deployment in the same cluster. Now, let us look at the various configurations of AVO AI workloads. Here is an example HA configuration with two nodes in the cluster. Node 1 is the primary replica and Node 2 is secondary synchronous replica. This is another example HA configuration with SQL Server running on the three nodes in a cluster. Here, Node 1 is the primary replica, Node 2 and Node 3 are secondary replicas. Here is another example DR configuration with three nodes in a site-aware cluster where Node 1 and 2 is part of Data Center 1 and Node 3 is in Data Center 2. Node 1 is primary replica, Node 2 and 3 are secondary replicas. Let us look at the solution deployment for AVO AI workload with 3-node HA configuration. When AVO AI workload is deployed on this 3-node configuration using Service Guard Manager, three packages are created. The first one is the SQL Server multi-node package to monitor the SQL Server process that runs on all the nodes. The second one is the availability group multi-node package that monitors the replicas on all the nodes and is the backbone of this workload. The third one is the write intent failover package that runs on the node which is the primary replica and makes the write IP available to applications. Let me demonstrate this deployment using Service Guard Manager. Log into Service Guard Manager. Go to Workloads. Click on Deploy Workload. Select Workload Type. Name your workload. Enter the Microsoft SQL Server credentials. As you can see, the availability group AG1 has two databases and Node BOY3 is the master replica. Select the availability group AG1. Select the subnet and enter the IP address used by the clients to write data. the email address if you're interested to receive the notifications. As mentioned earlier, the 3 workload packages are created. You can see the write intent failover package is running on the primary replica. From the SSMS Studio, we can see that Boy3 is the primary replica. Let us look at a failure scenario. Before the failure, both the replicas are healthy and the node 1 replica is primary. When the primary replica fails, Service Guard fails the write intent package on node 1. If the secondary replica is eligible, it is promoted as primary replica. Now, node 2 is the new primary replica. Let us look at the demo of AVO AI workload failure scenario. Let's run a script that writes into the database of availability group AG1. Let's start the database transaction. Now, let's simulate the failure by doing a reset of the node Boy3. As you can see, the database transaction has stopped. Now, the database transaction has resumed. The node Boy1 is promoted as a primary replica. Also, the DBs are in healthy state on the primary replica and secondary replica Boy4. The write intent package has failed over to the node Boy1, which is the new primary replica. Service Guard workload for AVO AI provides HADR for a single availability group. You can deploy multiple workloads for individual availability groups. You need an enterprise or instant-on license to deploy AVO AI workloads. This concludes the demonstration of providing HA and DR for SQL Server 2017 always-on availability groups using Service Guard's new workload for AVO AI. For more information on the Service Guard workloads for SQL Server on Linux, please refer the product documentation. Thank you.
All right. After taking a look at the Service Guard, HPE Service Guard option for setting up HA, it's now time for us to go ahead and take a look at this second day 2 operation that you would normally do once you configure your SQL Server. And that operation is about setting up the monitoring for SQL Server. So in this section, what I'm going to talk about are the different options using which you can set up the monitoring for SQL Server. So now let's go ahead and take a look at those options. The first option that I want to talk about is the PCP, which basically stands for Performance Copilot. Now, this is a method in which you can go ahead and set up monitoring for SQL Server, which basically has a controller node. And on this controller node, you have the PMCD, which is the daemon agent that is running, which collects the data. And then you have agents called as, agents for each of these applications. So if there is a database like SQL Server, you have a PMDA for that, which basically goes ahead and collects the data, specific to SQL Server, and then moves this data from the from the monitoring machine to the controller node. And I can have the controller, the PMCD also running on the same on the on the SQL Server that we are monitoring. Also, I can centrally keep the controller server as a central server and then have PMDA agents installed on all our SQL Server instances that we are going to monitor, and then collect the data centrally into one single place, and then use Grafana-based dashboards to actually go ahead and take a look at the data that has been collected by the PMCD daemon, which is stored by the PMCD daemon, but collected by the PMDA agents. So if you'd like to go ahead and set this up, I have provided you links with this, with the details on how you can go ahead and set this up. And there is also a blog that I've provided a reference here to, which you can go ahead and refer to set this PCP-based monitoring. The other monitoring that I want to talk about, or the other option that I want to talk about, is the option with Telegraph, Influx, and Grafana, which seems to be the more popular version of monitoring that I've seen at customer ends, where customers have gone ahead and implemented this. And in this, what we basically have is you can have any SQL server. So it could be a SQL server running on containers, SQL server running on Windows, SQL server running on Linux, be it any SQL server. You could just go ahead and to set this monitoring on those SQL Server instances, all you've got to do is create a login using which the Telegraph plugin can connect to the SQL Server, and then the data that it collects, it stores in an Influx DB, and then from the Influx DB, the data is pulled by the Grafana to actually showcase you the data dashboard. Now, I have a demo for this, which explains each of these steps here. And one thing that I would want to mention is in this diagram, I've put everything in one single host as containers. So my Telegraph is running as a separate container, Influx is running as another container, and Grafana is running as another container. Now, I would go ahead and show you a demo of this, but quickly talking about the various components. As I said, InfluxDB is used to store the data that is collected by Telegraph. And Telegraph has a plugin which connects to the SQL Server and gets the data from DMVs. And once it stores in the InfluxDB, that's when Grafana comes into the picture and starts to showcase that data which is being collected and stored in InfluxDB in a graphical format. Now, all the steps that I'm going to show you in the next demo is completely documented in the blog article that I've authored and listed here for your reference. And also I've given the reference to the Telegraph plugin that is being used inside this demo. So now let's go ahead and take a look at this demo.
It's now time for us to go ahead and take a look at how you can go ahead and set up near real-time monitoring for SQL Server running on Linux containers or even Windows using the Telegraph, Influx, and Grafana stack. Now, in this demo, what I'm going to do is I'm using this one single host, which is going to host all the three containers, and each of these containers is going to run each of the services that we are looking at. So we will be running Telegraph on one single container. We'll then run Influx on another one, and the third one is going to run Grafana. Now, because this is a demo, I am able to go ahead and run all the three containers on one single host. But depending upon the data that you're collecting and depending upon the resource utilization that's happening for Influx and for Telegraph, you might choose to actually go ahead and run each of these containers on different hosts, or you might just go ahead and run two containers on one single host and the third one probably another host. So that is something that you will have to take a look at and decide depending upon the resource utilization that you see. Now, that said, what are we going to do in this demo? So as I said, we are first going to go ahead and run three containers, each container running Telegraph, then the other one running Influx, and the last one running Grafana. Now, for these three containers to be able to talk to each other, we are going to have these containers deployed in the same network. So to do that, what we'll first go ahead and do is we'll go ahead and first create the network. So to create the network, the command I'm going to use is this. Now, again, please note, I'm not going to go ahead and do the creation now because I've already gone ahead and created it to save some time. So as you can see, the driver that I'm using for the network creation is Bridge, and the network name is InfluxDB Telegraph and Net. So yeah, you probably think this is way too big a name for a network to go. But with that said, once I go ahead and create this, you can go ahead and take a look at the network that gets created. So you can just say Docker network ls, and you will see this new network that we created is listed here. So now with the network created, it's time for us to go ahead and start deploying the containers. Now, the first container that we are going to deploy is the Telegraph. So for that, what the command is going to look like is something as shown here. So we are going to say Docker. So the command is going to be
docker run -d name of the container, and then I'm also hosting the telegraph.configuration file, which is on my host machine. So this is a modified telegraph configuration file, or should I say a customized telegraph configuration file, because this configuration file has the information of my target SQL servers that I need to kind of go ahead and monitor, right? So this telegraph.configuration file is what I'm mounting to the container inside the HC Telegraph, where the configuration file is, and then the network that I just went ahead and created, and the name of the container that I'm actually going ahead and creating. So again, I'm not going to go run this, but in fact, this is already done. So let's go ahead and now take a look at the configuration file that I have. So I have gone ahead and opened the configuration file in a Notepad++ for us to take a look at. As you can see, this is a configuration file which is also available as in the GitHub project where this plugin is defined. So you can go ahead and take a look at that plugin, and the reference for that is also provided in the presentation or the slide deck that we have. Now coming back to this configuration file, as you can see here, I have gone ahead and uncommented the database type. So I let the Telegraph plugin know that the database type it's going to connect is to SQL Server, and this is going to go ahead and by default collect the following data. As you can see, this is the data it's going to go ahead and collect. So it's going to go ahead and collect the performance counters, the weight statistics, the database IO, the server properties, and other information, all from DMV. Because this information is coming from DMVs, that is why this SQL Server basically, this plugin is basically going to work for SQL Server running on Windows or SQL Server on Linux or containers, because DMVs are present across all the SQL servers. Correct. So once we go ahead and ensure that we give the right database type to the plugin, it will be able to go ahead and connect to those SQL server. Now to connect to the SQL server, it still needs the information like what is the server, what is the port, what is the user ID that I need to go ahead and connect to. And that is the information that we provide here. As you can see, I provide my server, which is the IP address and the port 5433. This is the user that I've already created on this target machine, and this is the password for that user. Of course, this is not the password. This is just a made up password, but you understand the whole idea. So you basically provide all your target servers. So I provide all my target servers, and on all those target servers I've already gone ahead and created this user and the password for it, and that way it will be able to connect to these SQL servers and collect data. Now on if you have to take a look at this these SQL servers. So here are those SQL servers. So this is a SQL server which is running on Windows. This is a SQL server running on Windows. This is the Telegraph user that has been created. And as you can see, this Telegraph user that I've created, I've not given this a sysadmin permissions. In fact, this is just a normal Telegraph user that has been created without any sysadmin permissions. The only permission it has is the view server state and view server state information, and another one more permission that is just needed to view the DMVs, right? So only the information that is the permission that is required to view DMVs, that is only available with this user Telegraph. So once I go ahead and set my target servers and create those, the logins for them, I'm all set to start monitoring them. So the requirement to monitor any SQL server using this stack is that you need to go ahead and provide that information here, and you need to go ahead and create this user on the target SQL server. So once done, I can go back to my, let me go back here. So I can go back to my server where my Telegraph is running, and this configuration file is already uploaded. So with that done, it's now time for me to go ahead and set up the InfluxDB. Now InfluxDB is what is where the data will be stored once collected from the Telegraph. Now to do that, what I need to do is again run docker run, and this time I just need to go ahead and create the InfluxDB. As you can see, I'm using the InfluxDB 1.8 1.8 version. I'm not using the latest 2.0 versions, but rather I'm using 1.8 version. And again, I have set up or deployed this container inside the same network that I created. And I have provided a folder where this container can write to on the host. The reason for providing this folder is because the data can then be saved, so that if the container is stopped and restarted, I don't lose the data that is already present. And as you can see, the default port for 8086 is what I've mounted. So 8086 is mounted to the containers 8086 as well. So on this host, 8086 is now listening to the 8086 port, which is the default InfluxDB port, so that the data that Telegraph collects can be sent to this. And this information is also present inside inside the configuration file, where I specify that where my InfluxDB is running. So in this case, my InfluxDB is running on the same host, which is 10.0.0.24. This is the host on where my Influx container is running. So I basically say this is the host and this is the port number for it to go ahead and connect. And this is the database name that it needs to go ahead and load the data into. So this information is also provided in the plugin for the Telegraph. With all that information, the InfluxDB started. It's now time for us to go ahead and deploy the last piece of the puzzle, which is to deploy the Grafana database. Now, to deploy Grafana, I basically follow the same procedure. As you can see here, I am going ahead and running the Grafana service also as a container in the same network. And here I've exposed the port 3001 on my host to the default port 300, which is the Grafana port. And again, I'm just going ahead and providing a folder or a volume on my host where the container can go ahead and write the data. And these are the plugins that I'm going to use for my charts and dashboards. So these are the plugins I'm loading. So once done, I can go ahead now. The IP address of my host, if you look at the IP address of my host, it is 10.0.0.24. I cannot show this just for the security reasons, but you'd have to believe me that the IP address for this host is 10.0.0.24. So with that IP address, I can go ahead and connect to the Grafana at port 3001. So to show that, all I can do is I can quickly open up a portal here, and as you can see, I'm connected to 10.0.00.24 3001. So with that said, I have now set up my my Docker containers. So if I just do a Docker ps -a, you will see all the 3 containers up and running. So we are now ready to go ahead and set this up. Now, before we go ahead and set this up, the last part that we need to do is we need to set up Grafana. So if you are aware, or if you are if you've set up Grafana before, you might be aware of exact steps what you need to do. If you've not done that before, no worries, because the steps are very much documented over here on how you can go ahead and set up Grafana. So in this case, you will go ahead and log into the Grafana on this particular as per the information that you have here. So here I will replace this server name or IP address with 10.0.0.24, and 3000 will be 30001, because that's how that is the port on the host to which I've connected. And then I will set up the data source, which means I provide the InfluxDB location. Again, here it will be 10.0.0.24 and 8086, and then I should be able to load the dashboard. To load the dashboard, I go ahead and import the dashboard first. Again, the script or the YAML file for the importing of the dashboard is already provided in this location, so you can go ahead and load it there. So once you go ahead and do all of that, this is how your Grafana dashboard will look like. So if I just go back to my, let me just cancel. I don't want to save any. So let me just discard. Let me go back here. So once you have added the data, once you've gone ahead and created your data source and imported the dashboard, you can just go ahead and click on the dashboard. you will now be able to see all your information over here. So you can see the different instances that I'm collecting data. So I have an Ubuntu based container which is running. I also am collecting data from a Windows SQL Server running on Windows, SQL Server container which is running on RHEL 2 image, SQL Server on Linux. So these are all different SQL servers that I'm able to go ahead and collect the information. So I can see the SQL activities, I can see the CPU queuing and scheduling, wait stats, pretty much all the information that's available on the DMV is available over here. With that, our demo comes to an end, and it's now time for us to go back to the slide.
All right, with that demo, we come to a conclusion for this session. And I thank you for making time to attend this session. I hope you like the content. And if there are any questions that you have, I'm available now to answer those. Or you could also send those questions to me on LinkedIn and Twitter. My handle is Amvin, which is AMVIN 87. So you can go ahead and send me questions there. I'd be more than happy to answer, or you could go ahead and send your questions right away. We have another 10 minutes available for us to take questions and answers. Thank you, and looking forward to see you in my next session on containers.